What is meant by thermal expansion? So any body expands when it is heated, no? If you heat any body, its dimensions will increase. Similarly, if you cool any body, its dimensions will reduce. So we should have seen this one in opening and closing of doors, no? In summer season, the closing of doors, and in winter season, the closing and opening of doors, they will change. Okay? So all this is only because of thermal expansion. If temperature rises, dimensions of the body will increase. And if temperature falls down, dimensions of the body reduces. And the dimensions we will study in 3 conditions. We will study lengthwise change, area-wise change, and we will study volume-wise change. Okay? First one is called as linear expansion. Okay? What is meant by linear expansion? Expansion in the case of length of a body. How length will change when a body is heated. Okay? So now, for example, if I take a scale, so this is the initial length of the scale. Original length of the scale is L. So this scale, if I start heating this one, okay, then after some time I will observe that length of the scale has increased by this much amount, and this is called as a delta L. Okay, if you heat any body, its length will rise. So lengthwise expansion first we are studying. Original length is L, change in length is delta L. So delta L is the increase in length, number. So this delta L, it depends on initial length. What is the meaning of this one? What is the meaning of this? If original length is bigger, then for the same supply of heat energy, change in length will be bigger. Are you able to understand? What is the meaning of this one? For example, we are taking 2 rods. Okay, ma? We are taking 2 rods. Okay. And length of this rod is L, length of this rod is 2L. So this rod also I am heating, this rod also I am heating for same amount of time. Okay, ma? So consider here I am supplying 1000 joules of heat energy. So here also I am supplying 1000 joules of heat energy. Are you able to understand? Then in which condition the length will rise by bigger value? So here the change in length will be bigger. Why? Because its original length is bigger, no? So here change in length will be only this much. But here the change in length may be a bigger value when compared to this length. Understood, no? So here if I consider this one delta L1 and if I consider this one to be delta L2, definitely I can say delta L2 will be greater than delta L1. What is the reason? Reason is initial length of the rod is bigger, no? So therefore its expansion also will be bigger. So this is one point which we have to remember. So change in length is directly proportional to initial length. Okay. Second point is that change in length or expansion is directly proportional to change in temperature also. Okay, ma? So if you are rising temperature by greater value, then length also increases by greater value. So just if you are rising by 20 degrees Celsius, change in length will be very small. Same scale if you heat by 40 degrees Celsius, change in temperature, change in length will be double. Understood, Nama? So change in length depends on how many factors? Expansion depends on 2 factors. Initial length as well as rise in temperature. So delta T is called what here? Delta T is called as rise in temperature, or you can call it as change in temperature also you can call it as. Similarly, if temperature reduces, length also reduces. Temperature increase. Okay, ma? So this is what we were studying in the last class, Nama. For example, if you heat a rod, then there will be some elongation, or if you cool a rod, the length of the rod reduces. Okay. So change in length, delta L is called change in length. It can be either elongation also or compression also. So change in length is directly proportional to length, initial length. L means initial length here. And change in length is directly proportional to change in temperature also. So if you combine both of them, change in length is proportional to L delta T. And if you want to remove this proportionality symbol, we have to place a constant number, and that constant will be delta L is equals to alpha L delta T. Okay, ma? So here which is the proportionality constant? Alpha is the proportionality constant. Understood, no? So therefore, what is meant by alpha here? Alpha is nothing but the coefficient of linear expansion. Okay, ma? Coefficient of linear expansion is called as alpha. Are you able to understand, ma? So if alpha value increases, delta L value also increases. And this alpha value depends on nature of the material. So some materials, if you supply small amount of heat energy, they will expand by a large value. It means its alpha value is also greater. Some materials, they don't expand very much. It means their alpha value is lesser. That is the meaning of this one. So write down. So alpha depends on what? Alpha depends on nature of material. Okay? It depends on the nature of material. So therefore what I say, therefore if alpha is greater, okay, then change in length for particular change in temperature, is also greater. Okay, ma? For example, if you are taking two materials, ma, and you are changing the temperature by same value, then in one metal, the increase in alpha, the increase in length may be greater, and in another material, increase in length may be lesser. So whose alpha is greater? For that material which has expanded by greater value for same rise in temperature. For that one, alpha value is bigger. Understood, no? So how can I write equation of alpha here? Alpha can be written as delta L divided by L delta T. This is how you can write alpha value. Okay. Now can you say what is the definition of alpha, ma, by using this relation? Change in length per original length per change in temperature. That is called as alpha. Okay. So how much is the change in length of that particular body when compared to its original length, and when there is 1 degree rise in temperature, that is called as alpha value. Are you able to understand? Okay. Now see, ma, here there is one important point which you have to write here. Note point is that elongation is just like expansion of a photographic film. Okay. So elongation will be just like expansion of a photographic film. Now can you say what is meant by photographic film and how it elongates, ma? See, for example, you have taken a picture of something. Okay, ma? So this is the picture of Ashish. Understood, no? Okay, ma? So this is a photo of Ashish. So if you go to the laboratory, so this is a passport size first, and you want a very big size photo, A3 size photo you want. Then he can expand this one, no? So small photo he can make into a very big photo. So it means what are the dimensions which will change? Every dimension will change, no? Okay. So in this figure, his nose is only this much. Clear, no? But in the bigger figure, nose will be this much. Clear, no? So length of his hands are only this much. But in the bigger figure, length of hands also will increase. So here his hair is only this much. But in the bigger figure, length of hair will be very large. Understood, no? It means expansion of a photographic film means what? Expansion will take in every dimension and always in the outside direction only. Expansion always takes, it will be away from the center of this figure. And every dimension will change. For example, if you take this is the center of this figure, so expansion will be in this direction, expansion will be in this direction, in this direction, in this direction, in this direction, in this direction. In every direction, expansion will happen. Understood, no? So this is how photographic films, they will expand. So even when you heat bodies also, expansion is just similar to expansion of a photographic film. Okay? Expansion always take outwards and every dimension will increase. Therefore, for example, if you take a sheet of metal, okay, ma? You take a sheet of metal, consider this is a sheet of metal. Okay, so its initial temperature was T1 degrees Celsius and the final temperature is T2 degrees Celsius. So consider T2 is greater than T1. Okay, initially temperature was T1, now the temperature is T2. So you have increased the temperature. Therefore, this sheet will expand. Clear? How this sheet will expand? This sheet will expand area wise in every dimension. Understood? No? Therefore, for example, this is point A and this is point B. Okay? So this is the initial length between these 2 points. So there is one point A on this sheet and there is one more point on this sheet. Okay? So initial length between these 2 points is L. Okay? But if I am heating this sheet is not expanding lengthwise. Sheet is expanding area wise. Area is increasing. No? If you heat a rod, then you can say it will increase lengthwise. But metallic sheet, it will expand area wise. Okay? But to find out the final distance between these 2 points, initial distance is how much? Initial distance is L. So if I want to calculate the final distance between these 2 points, can I use the same formula or not? This formula can I use? Delta L is equals to L alpha delta T. What is delta L? Change in length. This is equals to L alpha delta T. I want only final distance between A and B only. I am not discussing about area. On the same metal sheet, I have taken 2 points. Okay, what is the distance between 2 points? L. I have heated this sheet. Then area of the sheet has increased. Area has increased. But I want a distance only between A and B. I want to find out whether distance between A and B has increased or decreased. Okay. My question is, can I use this formula or not? Can we use? No. Definitely we can use. Why we can use? That's what we have discussed, no? Okay. Expansion will take place in every dimension. Okay. Even the distance between A and B also will increase. So we are not discussing about total area, no? We are discussing about only distance between 2 points. That will increase. So definitely same relation you can use here also. So delta L is equals to L alpha delta T. Are you able to understand, ma? So make a note. So in the above case also, to find final change in length, okay, ma? We can use which relation? Delta L is equals to L alpha delta T. This relation definitely we can use. Okay. So not only in this condition. Now, for example, if you take, let us see. But completed, no, ma? Okay, see, ma. For example, I take a hollow sphere. So this is a hollow sphere. So inside a hollow sphere, there is one cavity. Okay, ma? What is meant by cavity? Cavity means there is some empty space. Are you able to understand? It means this is not a 100% solid sphere. You consider this is a type of hollow sphere. Are you able to understand, ma? So initial diameter is how much? Initial diameter of this one is D. The diameter of empty space is how much? Diameter of empty space is D. Okay, now I started heating this one. Now the question is, this diameter, will it increase or decrease? I am not discussing about diameter of total sphere. I am discussing about diameter of the empty space which is present. The diameter of the gap, the diameter of the cavity which is present. Its length, will it increase or not? Its length also increases, because already we said that expansion is like expansion of a photographic film, no? And photographic film always expands outsides. It doesn't expand inside. Expansion is always in outwards direction. So definitely diameter of this cavity also increases. So we write diameter of cavity increases. Understood, Nama? So to find out the change in diameter, again can't I use same relation? So delta L is equals to L alpha delta T. So delta D is equals to D alpha delta T. Definitely I can use this relation. Okay. Because diameter is area or it's only length only? Diameter is length only, no? So definitely you can use the relation for length. Okay. But expansion is area wise also, expansion is volume wise also. Total surface area of the sphere will increase, no? Similarly, total volume of the sphere also increases. Okay. But to find out a distance between 2 points, definitely you can use this relation, lengthwise expansion. Delta D is equals to D alpha delta D. Understood, Nama? So this is one point which you should be careful about, expansion in the case of bodies. So that is the most important point. Where is that point? I think I have rubbed this one. So elongation is just like expansion of a photographic film. This is the most important point. Clear? Write down. Okay. So then we study about the second type of expansion, which is called aerial expansion, or you can call it as superficial expansion. Okay. So aerial expansion means what? Expansion in terms of area of the body. For example, if you are taking a metal sheet and you are heating this one, initial area is A. Then what happens to final area? Final area of this sheet will definitely increase, no? So change in area, again you can write it is directly proportional to initial area. Okay, ma? So if initially area is greater, for same change in temperature, so delta A also will be greater. Delta A means what? Change in area also will be greater. If initially area is lesser, then for same change in temperature, change in area also will be lesser. Are you able to understand, ma? So change in area depends on initial area, and change in area also depends on change in temperature also. So if temperature is risen by greater value, it means you are supplying more heat energy, no? Then the expansion in area or increase in area also will be greater. Now if you combine both of them, what I write? I can write delta A is proportional to A delta T. You are combining both of them. Now again I want to remove this proportionality symbol, then I have to write beta into A delta T. And what is meant by beta here? Beta is called as the coefficient of aerial expansion or superficial expansion. Okay, ma? Okay. In linear expansion we have used alpha, no, ma? So here we are using beta. So therefore what is beta? Beta is equals to delta A divided by A delta T. This is the equation. Okay. Or you can write like this also. You can write it as A2 minus A1 divided by A1 into delta T. You can write like this also. Okay. So what is A1 and A2? A1 is equal to A is equal to initial area. Okay, ma? Similarly, A2 is called as final area. Okay. And delta T is called what? Delta T is called as change in temperature. Understood, no, ma? So this is beta value. Similarly, we can write the coefficient of volumetric expansion also, no? If increase is present in terms of volume, then we can write volumetric expansion. Okay. So write down. So volumetric expansion. So we are taking a solid sphere, ma? Solid sphere we are taking, and we are heating this one. Okay. Then initial volume is V1, final volume is V2. Then what is the change in volume? Change in volume is directly proportional to V, or you can call it as V1 also. Okay. And change in volume is directly proportional to change in temperature also. Same concept. Understood, no? So therefore if you combine both of them, what you will get? I will get. So change in volume is directly proportional to V delta T. This is what I will get. Understood, no? And if I want to remove this proportionality symbol, delta V is equals to gamma into V into delta T. Okay. And what is this gamma? Gamma is called as coefficient of volumetric expansion. Okay, this is gamma value. So gamma can also be written as delta V divided by V delta T. Understood, now? Or you can write V2 minus V1 divided by V1 into delta T. So you can write like this also. Okay. So the format of equations remains same for alpha as well as beta as well as gamma. Format of equations doesn't change. Same equations. Okay. So alpha you write in terms of length, beta you write in terms of area, volume you write, gamma you write in terms of volume. Understood, Nama? And there is a relation between alpha, beta and gamma for the same body. Clear? So write that relation also. So a relation between alpha, beta and gamma. Okay. There is some derivation. We are not going towards the derivation. Just write down the relation between them. So alpha is to beta is to gamma is equals to 1 is to 2 is to 3. This is the relation. Okay. So this is the relation between coefficient of linear expansion, coefficient of superficial expansion, and coefficient of volumetric expansion. Okay, 1:2:3. Therefore, you can write beta is equals to 2 times of alpha. Okay, ma? Or you can write gamma is equals to 3 times of alpha. You can write like this. Understood, no? Or similarly, you can write relation between beta and gamma also. Okay, ma? That's it. But there are 2 rods, no? 2 rods ఉన్నాయి కదా ఇక్కడ. Okay, ma? So therefore, this is the length of brass rod and this is the length of steel rod. 50 centimeter, 50 centimeter. So initial temperatures are at 40. My initial length is taken at 40. Now when you raise the temperature to 250 degrees Celsius, then what is the change in length of the combined rod? How can I calculate? Very simple. Change in length of total rod. How can I write? I can write change in length in the case of brass rod plus change in length in the case of steel rod. That's all, no? So temperature of both the rods is changing, no? Temperature of brass rod is also changing, temperature of steel rod is also changing. So both will expand, and they will expand outside, towards the outside. They will not expand towards the inside. They will expand towards the outside. So length of both rods will increase. And delta L values already we know, no? So delta L of total rod is equals to, what is delta L? L alpha delta T plus L alpha delta T. This is delta L, no? What is meant by first L? 50 centimeter. So shall I calculate in centimeters only? I will calculate in centimeters only, ma. So 50 into, what is alpha value? Alpha of brass is how much? This is brass, ma, and this is steel. Okay. So alpha of brass is, so 2 into 10 power minus 5. And what is the change in temperature? 250 minus 40 degrees. This is the change in temperature, no? Initial temperature was 40, final temperature was 250. So this is the change in temperature. Plus, again, calculation for steel rod. So this is also 50 only. So 2 into 10 power minus 5. What is the alpha value for brass, steel? 1.2. 1.2 into 10 power minus 5 multiplied by 210. Okay. So just to do this calculation, that will be the total change in length of the rod. Okay. And the answer which you should get is 0.34 centimeter, or individually you should get 0.21 plus 0.13. So total how much, ma? 0.34 centimeter. That is the change in length of total rod. Clear? Okay, ma? So let us see this question, ma. So there is a metal rod of length 25 centimeters, ma, and let us name this rod as rod A. Okay. So this is rod A, and what is its initial length? Its length is 25 centimeter. Clear, ma? And it expands by how much? It expands by 0.05 centimeter when temperature is raised from 0 to 100. It means the change in temperature is 100, ma. Change in temperature is 100 degrees Celsius. Okay. Then there is another rod. This is rod B. So different metal of length, and what is the length of this rod? Length of this rod is 40 centimeter. It expands by delta L value is how much? 0.04 for the same rise in temperature. So change in temperature here also it is 100 degrees Celsius only. So then there is a thin rod C of length 50 centimeter. So there is one more rod, ma, of C, made up of pieces of A and B. It means that this rod C, it is made up of 2 pieces. So up to here it is A and up to here it is B. And what is their individual lengths? That I don't know. Clear? So length of this rod, let it be L1. Length of this rod, let it be L2. Okay. Then what he is asking? It expands by 0.03 centimeter. So delta L of the total rod is how much? 0.03 centimeter on heating from. So here what is the change in temperature? 0 to 50, no? So 50 degrees is the rise in temperature. Then find the length of each portion of composite rod C. It means L1 and L2 values we are supposed to calculate. This is the question. Understood, no? So individually there are 2 rods, and by combining both of them we are making another rod. But their lengths we don't know. Which means how much part of A is taken, how much part of B is taken, that we don't have any idea. So those lengths only we are supposed to calculate. Understood, no? So delta L is given no in this condition. So therefore what I can do, delta L is nothing but delta L of rod A plus delta L of rod B. I can write like this now. So total change in length is change in length of first rod plus change in length of second rod. And what are the formula for delta L? L alpha delta T. So delta L is equals to LA alpha A delta T1 plus change in temperature is same, no? So you can write delta T only. And what about second rod? Length of second rod, coefficient of linear expansion of second rod multiplied by delta T. This is what I can write. And what is the initial length of this rod? Initial length is already given as 50 norma. That data we have missed here. So total length is how much? Total length is 50 centimeter. It means LA plus LB is how much? It is equal to 50 centimeter. Can I write like this? Length of first rod plus length of second rod is 50. But what is the individual lengths? I don't know. Okay. Now see ma here also I have LA, here also I have LB. And here also LA, LB. Two unknown quantities, two equations. Definitely I can solve them. Okay ma? Change in length we know. What is the change in length in the second condition? 0.03. So let us write. Okay. So 0.03 is equals to length of A multiplied by alpha A of A. How can I calculate from here? I can calculate alpha of first rod, no? Okay ma? What is alpha? Listen very careful ma. So alpha A is equals to delta L divided by L delta T. Clear? What is delta L? 0.05 divided by what is the original length? 25 multiplied by change in temperature is 100. You calculate this one, you will get alpha of the first rod. Then you calculate alpha of the second rod. Alpha B is how much? Again same relation. Delta L divided by L delta T. What is the change in length in second condition? 0.04 divided by initial length is 40 and change in temperature is 100. You calculate this one, you will get alpha of the second rod. Okay. And what are their values given? So 2 into 10 power minus 5 is this one. 2 into 10 power minus 5 per degree Celsius. And what about alpha of second rod? 10 power minus 5. So 1 into 10 power minus 5 per degree Celsius. These values I have got number. Now substitute the values in this equation. Alpha A is how much? So 2 into 10 power minus 5 multiplied by change in temperature is 50. Similarly for second rod, LB multiplied by alpha B. Alpha B already we have calculated, no? 10 power minus 5 multiplied by change in temperature is 50. Okay ma? So here you will get second equation. So this is my first equation and this is my second equation. Okay. So in first equation and second equation we have only two unknown quantities, no ma? LA, LB. Here also LA and LB. So can't you do this calculation? That's it. So calculate length of first rod, length of second rod. That's it. Okay ma? You can do one thing. You can take LB is equals to 50 minus LA. I can take like this, no? So wherever you find LB, here you are finding LB, substitute here. This is the third equation. Then you will get equation for LA. Once I will get LA, I will get LB also. And this calculation you have to do, I am not going to do it. So length of first rod is 10 centimeter. Length of second rod is 40 centimeter. This is the answer which you should do. Okay? That's it.